Hi guys, welcome to entry lessons, and we're going to be doing electrotechnology generators. And the first thing we are going to do is how to convert mechanical to electrical energy, guys. Okay guys, here when we're dealing with the generator, we are going to have to know what is the function of a generator. Which is the function of generator is to convert. The function of generator is to convert mechanical energy to electrical energy. Know that the function of generator is to convert mechanical energy to electrical energy. That means the power in is mechanical and the power out is electrical. The power in is mechanical and the power out is electrical. And guys, and this formula, energy is equals to power times time. Remember that energy is equals to power times time, and energy is measured in joules, guys. And to operate the generator, you have to know Faraday's law. To operate a generator, you have to know Faraday's law, which this law means for your power in, there has to be magnetic flux field coil, and a rotation. Okay guys, Faraday's laws means that during a rotation in the presence of the field coil, the magnetic flux is cut. It is cut, and then this is step one. When there is a rotation, the magnetic flux is cut in the presence of the magnetic field. Let me just write it. It means when there is rotation, magnetic coil is cut to produce magnetic flux in the presence of magnetic field. In the presence of magnetic field. This is step number one, which includes magnetic flux, field coil, and the rotation. It means that when there is a rotation, magnetic coil is cut to produce magnetic flux in the presence of magnetic field. And then guys, there will be step two, and magnetic flux, which is cut. Magnetic flux, which is cut. The magnetic flux, which is cut, will induce EMF, and the induced EMF will produce current. This is step number 2. And the last step, the Faraday's laws means that when there is a rotation, magnetic coil is cut to produce magnetic flux in the presence of magnetic field. And number 2, those magnetic flux will then be cut, will induce the EMF, and the induced EMF will produce current. So that is how electricity is produced. First, you need a rotation. Then you need magnetic flux. Field coil to produce EMF, and the produced EMF will give us current. You need magnetic flux, field coil, and a rotation in the presence of magnetic field, which will induce EMF, and the induced EMF will produce current. Okay guys, and in order to create that rotation, we need something we call prime movers. Rotation is caused by prime movers. And what are prime movers? Prime movers is a natural or a prime mover is a natural or mechanical source It's a natural or mechanical source which causes angular motion. It is a natural or mechanical source which causes angular motions, and the examples are a turbine, petrol, diesel, engine. And these are the examples of prime movers. It is a turbine, a petrol, diesel, sorry about the spelling of diesel, and an engine. It is a natural or mechanical source which provide or produce or causes angular motion. And the examples is turbine, petrol, diesel, and an engine. And guys, that is how electricity is generated, or how it is converted from mechanical to electrical. It is converted from, a summary, it is converted from mechanical to electrical energy by the use of prime movers. Prime movers cause a rotation within a generator. It causes a generation, and during that rotation there is a field coil which is cut into the magnetic flux, which then will be induced to cause EMF, to produce EMF, and the produced EMF will produce the current. And yes, its operation, it is caused we can say it is described by Faraday's laws, and that is how power is generated from mechanical to electrical during the operation of generator. Okay guys, and now we're gonna talk about commutation. Commutation, guys, what is a commutation? Commutation is a reversal. Commutation is the reversal of current. Commutation is the reversal of current that occurs within an instant. It is a reversal of current which occurs within an instant when the circuit is short. When the circuit is short, it is the reversal of the current which occurs within an instant when the circuit is short-circuited. See? And guys, when the circuit is short-circuited, guys, it causes sparks. It causes sparks, guys. When the circuit is short-circuited, it causes sparks, and this circuit is short-circuited by brushes. Know that it is a reversal of the current which occurs within an instant when the circuit is short-circuited by the brushes, and which will causes sparks. Okay guys, so the effect of commutation or the causes of sparks is commutation. See, the effect of commutation is sparks, and what causes sparks is because of commutation, guys. Okay, let's talk about sparks. Sparks, guys. Guys, you know when you turn the lights on and off, there is that cracking sound, right? There is that cracking sound, guys. What causes that cracking sound, guys? Let me tell you. Here is the brushes. Here is the brushes, and here is commutator. And here is the energy, right? The energy. The electrical energy. Guys, here is, guys, first of all, energy moves from high potential or high area to lower area. That means the commutator is within the high area and the brushes are in the low area. So it is caused by when the energy, electrical energy, moves from high potential to the low potential, and when it reaches between the commutator and the brushes, that sparks is caused because the area it's about to leave or to separate, you know, it is about to separate or to make a contact from commutator to brushes. Okay guys, so to explain this in simpler terms, to summarize it guys, it just basically means that energy jumps from high potential region here to a lower potential region. Know that. And when it moves from high potential to lower potential, guys, know that there is a current flowing between commutator and brushes, And when the current is about to leave from the contact from commutator and the brushes, or about to separate, it causes that cracking sound, which are the sparks, guys. Sparks, it is when the electrical energy or the current is about to leave from a higher potential region to a lower potential region between commutator and the brushes, guys. And then sparks is the effect of commutation, and commutation is the reversal of the current that occurs within an instant when the circuit is short-circuited by the brushes, guys. That is the summary of commutation. And guys, there are methods to reduce sparks. There are 4 methods, guys. The first method is to increase the resistance. The first one is to increase the resistance of brushes. So people who do that will remove low resistance brushes and buy high resistance brushes. Is to increase the resistance of brushes. And number 2, to use compensating winding. To use compensating windings, guys. The first one is to increase the resistance of the brushes. The second one is to use compensating windings. And the third one is to shift the brush. Is to shift the brush forward in a generator, and to shift the brush backwards in the motor. And the last but not least is to use interpole. Interpole is connected in the middle between the other poles in magnetic field, guys. So the first one is to increase the resistance of the brushes, remove the lower resistance one to higher, and to use compensating windings. The third one is to shift the brushes forward in a generator and backwards in a motor, and to use interpole, which is connected in the middle within the magnetic field. And guys, there are functions of interpoles. The functions of interpoles, the first one is to reduce sparks during commutation, and the other one is to reduce sparks during commutation and to neutralize magnetizing effect that causes armature reactions. Guys, we will learn about armature reactions while in a new topic in module 4, when we still continue with our lessons. Okay, guys, is to reduce sparks during commutation. The other one is to neutralize magnetizing effect that causes armature reactions. Guys, that was the functions, that was the methods to reduce sparks, guys. And in interpole has functions. They might ask you the functions of interpoles during the exams. That's why I did them, because I normally see them within the exams, guys. Okay, guys, and now, guys, let's talk about, guys, okay, let me just say the EMF is dependent on, guys, know that the EMF is independent on magnetic flux density. The length of armature. The length or number of armature contacts. Guys, the length or number. So magnetic flux density, length of armature, or the number of armature contacts, and number of poles. Last but not least, the rate at which magnetic flux is cut. Number one is magnetic flux density. Number two, length or number of armature contacts, and number of poles, and the rate at which magnetic flux is cut. Number four. Okay, guys, and now we move to excitation, guys. To excite a coil, or to energize a coil. To excite a coil or to energize a coil is to allow current. This is current, guys. This is a symbol of current. Is to allow current to pass through that coil. Excitation is to excite or to energize a coil, is to allow current to pass through that coil so that the coil becomes electromagnet. To excite or to energize a coil is to allow current to pass through that coil so that it becomes electromagnet, guys. And there are two ways to excite a coil. We have self-exciting, and we have it's self-exciting and separately exciting machines. Okay, guys, so let's start with separately. Guys, remember this topic is still about generators, right? So guys, let's start with separately exciting generators. Okay, guys, for separately exciting generators, it consists of a battery or another generator. I'm not going to write the whole thing. Battery. So for self-exciting generators, it consists of a battery or another generator as its source of external as its source of external, sorry, it's supposed to be a C, right? As its source of external energy. You see, for its external energy, it includes, English guys, sorry, it includes a battery or another generator, which means it will reach higher voltage and its maximum EMF quickly because of that help from a battery or another generator as its external source. You see, yeah, yes guys, and let's just throw it fast. It is separately, so the coil and the armature will be separated. Here is the coil, guys. Yeah. This is the armature. And that external source of energy. You see, for separated excited generators, they are separated, the armature and the field coil. This is the field coil. The armature and the field coil are separated, guys, and it has a battery or another generator as its source, you see, as its external source. And since it has a battery and another generator as its external source, it will reach higher voltage and maximum EMF faster because of the battery produces stronger current, which will create stronger magnetic field. Okay guys, so for separately exciting generators, we have a magnetizing curve. Magnetizing curve includes of a web. This is a Weber, and the field coil. The field coil, it will increase. They will both increase until it reaches a point of saturation. You see, know this, the magnetizing curve include of a Weber and a field coil, guys. The current of the field coil, which both Web and field current will increase until it reach a point of saturation. A point of saturation is a point beyond which no more can be absorbed or produced. It cannot no longer be, it can no longer increase. This beyond this point, no more can be absorbed or produced. Okay guys, and we also have a load characteristics, guys. Okay guys, so let's return here again. A Weber and a field coil they increase proportionally. They both increase at the same time until they can no longer increase. And then for the load characteristics, guys, includes of a voltage and a load current. That's why we call it a load characteristics, because it includes of a voltage and a load current, and they will also rise at the same time until the voltage drop. Why did the voltage drop? The voltage dropped because of the armature reaction and the increasing armature voltage drop. That is why it is dropped. And the application, guys, we use self-exciting generators in automatic system controller. Okay, guys, and this is very important. This formula, V minus E, V is equals to E minus IA RA. This is the armature current and this is the armature resistant or resistor. It's very important when it comes to separated excited generators, guys, and that is all about separated exciting generators. And now we move on to self-exciting generators. Okay, guys, so for self-exciting generators, this one, they create their own current, guys. They create their own current by depending on residual magnetic flux, guys. Self-exciting generators, they produce their own current by operating on residual magnetic flux, guys. So what is the residual magnetic flux, guys? Residual magnetic flux is the magnetic flux that gets left behind during magnetizing, guys. It is left behind during magnetizing. But yeah, the definition is magnetic flux remain in the field system even after magnetizing is removed. So it remained behind even after magnetizing is removed, guys. That is the definition, you must know it. And guys, self-exciting generators, we have 3 self-exciting generators. It includes of series wound generator, parallel or shunt wound, and compound wound, guys. 3 generators: series wound, parallel wound or shunt wound, and compound wound. Compound wound is the mixture of both series wound and parallel wounded generators. Okay, guys, and now we know the definition of residual magnetic flux. Let's go to how it is operated, guys. Okay, guys. Okay, guys. So remember, guys, to operate a generator, we need a coil, a rotation, and the magnetic flux. Remember, so there is a rotation caused by armature conductors. A rotation is caused by armature conductors, which will then we have magnetic flux, guys, remember, which then the residual magnetic flux are cut, and this residual magnetic flux which are cut, they will create a small EMF, and that small EMF will create a smaller current, which then the whole generator will be maintained by a smaller residual magnetic flux, smaller current, smaller EMF, which then will create smaller current. So the whole generator is maintained by smaller current. Remember, on the separately exciting, because it has a battery and another generator as its source of external voltage, it is fire, it is much more faster, and it reaches maximum EMF and maximum current much faster. So this one, it is slower because it creates its own current. That means it has to maintain the magnetic field. It has to maintain that magnetic field so that residual magnetic flux can remain behind after magnetizing, yeah, which leads to smaller EMF, smaller current until it reaches its maximum EMF.